Hey guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this GFG problem of the day, find prime numbers in a range. So let's move on to the problem. Here we are given two integers m and we have to find out all the prime numbers between m and n. Like if our m is equal to 1 and our n is equal to 10, then 2, 3, 5 and 7 are the prime numbers between 1 and 10. Similarly here 2, 3, 5 between 2 and 5. Okay, so and the time complexity is n square n into square root of n. Okay, so here how we solve it. So first of all, this is given function to us. Okay, and this is our vector that we take to store our all the prime numbers that we will find out. Okay, so we will run a loop for I is equal to max m comma 2. I will tell you why I use this max m comma 2 and till n, and we are increment I in each iteration. Okay, so if we will take a variable o and initialize it with 1, then we will run a loop from j is equal to 2 to j into j less than or is equal to I. Okay, j into j less than is equal to I means I am saying j square less than or is equal to I. Okay, so it means my j always be less than or is equal to I. Okay, so my loop will work for this many times. Okay, my loop will work for under root I times maximum. Okay, and for when we generalize it for all the i's, my loop will work for I plus root I plus up to n times. Okay, up to n times. So what we can say, our final time complexity is equal to n times of root n. Okay, n times of root n, that will fit our required time complexity. Okay guys, so why are we doing it? Like if we have number 8. Okay, we know it is not prime and we will also see for example 11. Okay, so first of all we will see for 8. Now the all the divisors of 8, because it is not prime, we all know, that's why it also have some divisors greater than 1 like 2, 4. Okay, these are the two divisors of it. Now we will take the value of under root 8. Under root 8 is equal to some 2 point something, 2 point something like 2.8 something it will. Okay, so now if this is our uh, number line and this is 8, this is 8 by 2 means 4, and this is under root of 8, this is under root of 8. So we are running our loop for this much time. Why we are doing so? Because if we have some factor beyond this, then we will find out a factor in this also, because as you know a into b is equal to I. Okay, if I is a factor between this, then b is equal to I divided by a, b is equal to I divided by a. Okay, so if I got this a, my 8 is divided by a in this range and it will also be divided by b in this range, but I need to find out whether it is rhyme or not. Then I will only need a single factor. So if I found any a, then I don't need to found this b. Okay, so I can run a loop till n square, square root of n, sorry. And you can see this for all the example, like for 45, all the divisors of 45 is 3 comma 5 comma 9 comma 15 comma 30. No, it, okay, 15, yes, these are the only factors I think. Yes, okay, and the under root of 45 is, under root of 45 is equal to 6 point something, is equal to 6 point something. So if we check for 3 and 5, you can see 15 into 3 is equal to 45 and 9 into 5 is equal to 45. Okay, so one factor is less than the square root and one factor is greater than the square root. So if we found a factor that is less than the square root, then we can tell we have a factor to for which our number is divided. Like here we found number 3 for which our 45 will be divided by 3. Hence we don't need to find out this 15. Hence it will decrease our time complexity from on to square root of n. So our overall time complexity will decrease from on into n to n into root n. Changing the color I am. Okay. This n is basically for each number between m and n, because I have to turn a loop between n and m, and this n for calculating the prime. For calculating the prime. Just a minute. For calculating a prime, you can see the first n because of this, and the second is square root of n because of this function. I hope you all understand it. And for 11, as I told you, I will take 11 as example also. The factor of 11 are none. Okay, so and you will turn a loop till under root square root of 11, that is equal to 3 point something. So you will just check for 2 and 3, unless if you check for all the 11s, then you have to run this loop for 2 to 11 times. Okay, so it will decrease your 10 your 10 iterations to only 2 iterations. Okay, to only 2 iterations. So it will decrease your time limit to a very huge amount. Okay, so I hope you all understand it. And if I found a divisor, then I just make o is equal to 0 and I just break out. And if my o is equal to still 1, then I just post back the answer. Now while why I am taking the maximum of m comma 2, like if my m is equal to 1, then because you can see I am starting my j from 2, so this loop will not work for my o is equal, for my m is equal to 1, because my j is equal to 2, starting index of j is greater than my I. Okay, so I or remains 1, or remains 1, that's why I also push back 1 here. Okay, if we started from n, then I will check here a condition I is not is equal to 1. Here I will need to check a condition my I should not be equal to 1. As well we will show 1 in all in answer also. Okay, you can see. So guys, you can see all the 116 all the 1016 cases are passed, and time taken is also very low. So I hope you all understand it. I explain it to my best. I explain it to my best. Okay, so and still if you have any doubt, then just comment out. I will try my best to explain you. So guys, please subscribe the channel, like the video, and check out my channel for more GFG and lead code daily problems solution. Thank you for watching this, guys.